Welcome to another edition of Math for No Reason. In this edition, we are going to prove the well-known Cauchy-Schwarz inequality. The Cauchy-Schwarz inequality states that if we have two sets of real numbers, a1 into an and b1 into bn, then the absolute value of summation I is equal to 1 to n ai into bi must be less than or equal to the square root of summation I is equal to 1 to n ai square into summation I is equal to 1 to n bi square. Now to prove this, we will consider a function ft, and this is defined as summation I is equal to 1 to n ait plus bi whole square. Note that this is a sum of squares, therefore f of t has to be greater than or equal to 0 for all real values of t. Now expanding this, we get summation I is equal to 1 to n ai square t square plus twice summation I is equal to 1 to n ai bi into t plus summation I is equal to 1 to n bi. Now we will denote this as at square plus bt plus c. Now since ft is greater than or equal to 0 for all t, we know that from the theory of quadratic equations, the discriminant of this quadratic expression must be less than or equal to 0. So therefore 4b square minus 4ac must be less than or equal to 0, or b square must be less than or equal to ac. Taking square root on both sides, we get mod of b is less than or equal to square root of ac. Now putting back the quantities for in place of the symbols ABC, we get summation I is equal to 1 to n ai bi. Absolute value of that is less than or equal to square root of summation I is equal to 1 to n ai square into summation I is equal to 1 to n bi square, which is the Cauchy-Schwarz inequality. When equality happens in this Cauchy-Schwarz inequality, the discriminant is equal to 0. Now the discriminant is equal to 0 means that the expression ft is equal to 0 has a real root. That means there is a value of t for which ft is equal to 0. So remember that ft is summation of I is equal to 1 to n ait plus bi whole square. Now if this is to be 0, then each of these terms ait plus bi must be equal to 0. That means ait plus bi is equal to 0 for some t. That means that we must have t is equal to minus bi by ai for all the values of I from 1 to n. That means that a1 by b1 must be equal to a2 by b2 must be equal to an by bn. That is, the AIs are proportional to BIs. It's a good place to stop. Thank you.